Good day. Today is the continuation of our lesson about number sequences under the first quarter of grade 10 mathematics. But this time, we're going to discuss the concept under our second objective, which is all about illustrating an arithmetic sequence. Review session. Describe the pattern on each number sequence below. So we have the first pattern or number sequence 2, 4, 6, 8, 10. Our second 15, 12, 9, 6, and 3. And our third number sequence is negative 5, negative 4, negative 3, negative 2, and negative 1. I want you to observe our first number sequence. You're correct. In this specific number sequence, each term is obtained by adding 2 to the previous term. Considering this 4 is obtained by adding 2 from 2. So 2 plus 2, we have 4. And to get 6, definitely, we need to add a constant number of 2 from its previous number, which is 4. So we get 6, and so on and so forth. For our second number sequence, each term is obtained by adding a constant number, which is negative 3 to the previous term. So here, our first term is 15. To get the second term, we add negative 3, so we obtain 12, and we add negative 3 from 12, so we obtain 9. Following the same pattern, then we will obtain this specific number sequence. For our third example, we have negative 5, negative 4, negative 3, negative 2, and negative 1. Yes, you're correct. Each pattern is obtained by adding positive 1 to the previous term. So our first term here is negative 5. So we add positive 1 to negative 5. That's why we obtain here negative 4. Same, we add again positive 1 to negative 4. So we obtain negative 3. And of course, following or adding the same constant from the previous term to get the successive, well, of course, following this number sequence. Our examples, A, or the number sequence under A, under B, and under C are all examples of what we call arithmetic sequence. Now, what is an arithmetic sequence? In mathematics, an arithmetic sequence or arithmetic progression is a sequence of numbers where each term after the first term is obtained by adding a constant. And this constant is called the common difference, denoted by variable d. Take note, this is a type of a number sequence wherein numbers or the next term or the successive term is obtained by adding a constant from a preceding term. So to give you a clear understanding about arithmetic progression or arithmetic sequence, then let's consider this illustrative example. In this illustrative example, we have a number sequence of 1, 4, 7, 10, 13, and 16. In a number line, we can write it like this. So as what you observe, in this specific sequence, we add a constant positive 3 to get the next succeeding term. So considering the first term, which is 1, we add the constant or the common difference 3. So our second term will be 4. And from that 4, we add again the common difference 3. So our next term will be 7. The next term after 7 will be 10. The next term after that will be 13. And so on. So let's move on here on examples and non-example of arithmetic sequence. We have here the first set of number, the second, and the third number sequence. I want you to focus on our first number sequence. I want you to observe the difference between each successive terms. So here, the difference between 10 and 5 is of course 5. The difference between 15 and 10, that is 5. The difference between 20 and 15 is still 5. Therefore, we can conclude that this number sequence is an example of arithmetic sequence since it has a common difference of 5. Considering our second example, so we got here B, 3, 12, 48, and 192. So in this second number sequence, as what you observe, we can see an equal difference because when we subtract 3 from 12, we will obtain 9. But when we subtract 12 from 48, we will obtain 36. So, they don't have any common difference. Since that is our observation about the second number sequence, then we can say that this number sequence is not an arithmetic sequence because it has no common difference. Let's move on to our third example or number sequence. So we got here 1, 1 half, 0, negative 1 half, negative 1. So as what you observe, when we subtract 1 from 1 half, then we'll obtain a difference of negative 1 half. When we subtract 1 half from 0, then we will obtain negative 1 half. When we subtract 0 from negative 1 half, the difference is negative 1 half. You're correct. This is an example of an arithmetic sequence. Why? Because each term is obtained by adding negative 1 half to the previous term. Therefore, it is an arithmetic sequence. Let's move on for more illustrative examples. Here, determine if the given sequence is an arithmetic sequence or not an arithmetic sequence. So these are the given. So for the first one, what do you think? Is this an arithmetic sequence or not an arithmetic sequence? Before answering this, I want you to focus on the difference between the successive terms. So here, 7 minus 3, we get 4. 11 minus 7, we get 4. 15 minus 11, we got 4. For 19 minus 15, we got 4. As what you observe, they have a common difference. Then, since that is the case, you're correct. That is an arithmetic sequence. Let's move on to the second number sequence. So we got 4, 16, 64, 256. So in this second item, as what you observe, if we subtract 4 from 16, we'd be able to obtain a difference of 12. And that is not actually equal on a difference when we subtract 16 from 64. Therefore, since they don't have a common difference, that number 2 is not an arithmetic sequence. Take note, under this second item is not an arithmetic sequence. Let's move on to our number 3 item. 48, 24, 12, 6, and 3. Now, considering the test, we got 24 minus 48. Then we have there negative 24. We got 12 minus 24. The difference is negative 12. As what you observe, the difference are not actually equal. Therefore, this item number 3 is not an arithmetic sequence. Moving on for item number 4. For item number 4, we got here 1, 4, 9, 16, 25, 36. So, let's try to identify the difference between 4 and 1. That's 3. Between 9 and 4, that is 5. between 16 and 9, that is 7. So as what you observe, we do not have a common difference. Therefore, we conclude that this number sequence under item number 4 is not an arithmetic sequence. Now let's move on to item number 5. We got here the first term, which is equal to 1. When we subtract the second term from the first term, then we will obtain negative 1/2. And here, when we subtract 1/2 from 0, we will obtain still negative 1/2. And again, when we subtract 0 from negative 1/2, still we will obtain a difference of negative 1/2. Therefore, in this item number 5, it has a common difference of negative 1/2. Therefore, we can conclude that item number 5 is an arithmetic sequence. Considering our item number 6, we got here negative 2, 4, negative 8, and 16. I want you to observe the difference of 4 and negative 2. The difference between these two numbers, 4 minus negative 2, the answer is 6. But the difference between negative 8 less 4, that is negative 12. So, as what you observe, we do not have a consistent difference. It will yield to a conclusion that this item 6 is not an arithmetic sequence. Moving on to item number 7. We get here the first term is 1, the second term is 0. So we subtract 0 minus 1. So we got negative 1 as difference. When we subtract 0 from negative 1, still we have difference of negative 1. When we subtract negative 1 from negative 2, still we have a common difference of negative 1. So, since that is the condition, therefore, 7 is an example of an arithmetic sequence. Let's move on to item number 8. So we have 1/2, 1/3, 1/4, and 1/5. In this case, as what you observe, obviously the difference between 1/3 and 1/2 is not actually equal on a difference of 1/4 and 1/3. It is very obvious. Since that is the case, then we conclude that item 8 is not an arithmetic sequence. Moving on to item number 9. So we got here 3x, the second term is x, the third term is x over 3, and the fourth term is x over 9. So when we subtract x minus 3x, then the answer is negative 2x. And that difference is not actually equal when we subtract this x from x over 3. Since that is the case, then this 9 is not an arithmetic sequence. Let's move on to our last item for our illustrative example. So we got here 9.5, 7.5, 5.5, and 3.5. Let's try to subtract 7.5 and 9.5. So we will obtain there a difference of negative 2. Correct. Let's try to subtract again the second term from the third term. So 7.5 subtract from 5.5, then our difference is again negative 2. For this, we got here 5.5, we subtract that from 3.5, again we will obtain a difference of negative 2. Obviously, we have a common difference for item number 10. Therefore, this item number 10 is an example of what we call arithmetic sequence. I hope you learned a lot from this session about arithmetic sequence and on how to determine if a number sequence is an arithmetic or not an arithmetic sequence. Good day and thank you for watching.